Kartika and I am pursuing my Bachelor's of Technology in Computer Science and Engineering from Guru Nanak Dev Engineering College, Ludhiana. This is the task 2 under internship of the Spark Foundation. This task was to do prediction using unsupervised learning, and the unsupervised learning algorithm used here was K-means clustering. So we will implement K-means clustering algorithm in this task. How does this K-means algorithm work? In this algorithm, we first select the K. K is the number of clusters or the number of centroids. We can select the K points or K centroids randomly. It could be some points other from the input dataset as well. Then we try to assign the data points which are closest to these centroids. We calculate the variance and place a new centroid of a cluster. We repeat these steps till the reassignment. Every time we assign the data point to the closest cluster so that we can find the best patterns in the data. So here we will be first importing all the libraries like NumPy, Matplotlib, Pandas, sklearn, and we had load the Iris dataset. This dataset, using the Pandas, I had tried to import the first 5 rows of this dataset, including the features sepal length, sepal width, petal length, petal width. This is the data for 5 rows. Using shape feature of Pandas, iris_df.shape, I tried to know how many rows and columns of the data. There are 150 rows and 4 columns. Telling you more about the Iris dataset, this dataset consists of data for 50 flowers, and these 50 flowers are of 3 species. That means 50 flowers of each species. So 50 into 3, 150 rows. The 3 species are Setosa, versicolor, virginica. The goal here is to analyze the data and build the clusters of the data, because looking at the data you cannot tell which is Setosa, which is versicolor and which is virginica. So we'll try to find that by knowing the various features of the data and patterns of the data. So this describe feature of Pandas, what it does is it tells about the count, mean, standard deviation, minimum, quartile values and the maximum values. This is not required for K-means clustering, but we can use this feature for data analysis. Now, how to find the optimal number of clusters for K-means? That is how to find the value of K. In this there are various methods, but for this task I had used the elbow method. In elbow method we use WCSS, which is within cluster sum of square. Within cluster sum of square is the sum of square distance between the centroid and the data points. We try to find that distance. We try to find out how many clusters can be possible with the minimum distance in the different data points. So what we do is, number of clusters we take from 1 to 11, and on the x-axis 0 to the nearly 700 we take within cluster sum of square values. As you can see, when the number of clusters are 1, within cluster sum of square value is the maximum, and it keep on decreasing with the increase in number of clusters. And wherever you see this elbow, you can see this is the peak point, the elbow point, which is at the point number 3. So value of K we take is 3. So this is the value of K, which is 3. Now we know the number of clusters. Now we can apply K-means to our data set. We create this classifier with number of clusters equal to 3, and maximum iteration is 300, random state is to 0, and we initialize the various values. And then we are going to plot these values using the feature of Matplotlib. As you can see, the first cluster is values are given the color red, and the label for that values. As I said, there are three species. So the first species Iris setosa, second is color blue, and the species is Iris versicolor. Third is the color green, and the species or the label here is Iris virginica. Okay, so then we are going to plot the centroids of the cluster. The centroids are given the yellow color. As you can see in this graph, blue colors are versicolors, green is virginica, and red is Iris setosa. And for each of these clusters, these yellow points are its centroids, center points of the clusters. So this way we can tell which flower belongs to which species. Only from the data 4 features given, we had tried to find the various patterns and the insights of the data with this unsupervised K-means clustering algorithm. Thank you for your patient listening. The code for this task has been uploaded in GitHub link, which I had provided in the description link. Thank you.